Right, when you buy a battery from the shops, it does get printed on there the actual voltage of the cell itself, and that's what we're going to talk about today. So if you buy a cell, let's just say you bought an AA cell from the shops, so this is an AA battery from the shops, it normally it gets printed on there that this is 1.5 volts. So this here is never actually 1.5 volts, and that's because inside here there is a tiny bit of resistance itself, so you don't actually get 1.5 volts out of it. The number is a bit less. So that's what we're going to investigate, and that is what internal resistance is all about. So if you were to draw a cell like this, the way we showcase internal resistance is we put a resistor, just like I've added a resistor in here. We add a resistor to this circuit like this, and then we call this small r, which is quite important. And then what we normally do is we normally put dots around here to showcase or to highlight that it has got internal resistance of its own. So what we're going to do is we're going to add in a resistor over here, and this resistor over here is actually big R. So what we've got at the moment then, we've got 1.5 volts over here, which is basically the label on the AA battery. We've got the internal resistance, and we've got big R, which is the resistance of this resistor over here. So the total resistance of the circuit is not just R, it's actually R plus little r. So we're going to remember that as well. So that's the total resistance of the circuit itself. The EMF, or epsilon, so the EMF of the cell, what basically is printed on the label is actually equal to the voltage in the circuit plus, so the voltage in the circuit is actually what the voltage the components are using up, plus the voltage lost in the cell itself. So that's what we've got at the moment. So that's the equation we're going to use. So essentially then, we're going to use Ohm's law. We're going to say, as we know, V is equal to IR, we're going to say that epsilon, and epsilon's units, we can write down over here, epsilon in this case is 1.5 volts, and the units are volts for epsilon, or the EMF of the cell, is actually equal to the current in the circuit plus the voltage, the resistance in the circuit. So we times those two together, plus the voltage lost in the cell. So we do I plus R. So we do that plus that, and then therefore the total EMF is actually equal to I R plus R. So that's how we calculate the EMF of a cell.